Hey, it's Professor Dave. I want to tell you about classical physics.
He knows a lot about the science stuff. Professor Dave explains.
Let's go back in time to the dawn of man. Homo sapiens will live in small tribes for hundreds of thousands of years, struggling to survive. But as these tribes grow and merge, their cultures merge, and eventually written language evolves. This is the beginning of recorded history and the dawn of modern civilization. In these early centers of culture, like ancient Greece, great thinkers would gather to discuss ideas and ask questions. What are we? What is the universe made of? How does it behave? The analysis that was prompted by these questions was labeled natural philosophy, a singular field of study that encompassed science, philosophy, and religion, as these were more or less one topic back then. Philosophers made conjectures about what they could observe, the form and properties of matter, and the changes matter can undergo. But over the centuries, our understanding of the universe progressed until we arrived at figures like Galileo and Newton, who brought about the birth of classical physics. What was incredible about this time was the realization that everything in the universe operates according to certain principles. Principles that can be known, understood, and described using mathematics. The implications of this are astonishing. It means that if we drop an object off the top of a tall building, there is a mathematical equation that predicts how fast the ball will drop, precisely where it will be at any given instant, and so forth. This means that the motion of any object in the universe is not random, but is instead quantifiable, calculable, and predictable, whether we are talking about a pebble or a galaxy. In this way, classical physics was able to take the chaotic and mysterious world of our ancestors and transform it into a landscape of mathematical order. Whether this idea seems off-putting or exciting, we have to accept that the universe is math, because when we use these equations to make highly precise predictions about how an object will behave, the correlation with real events is undeniable. It is precisely this kind of math that allows us to fly airplanes, build roller coasters, and even send astronauts to the moon. At the beginning of the 20th century, advancements made by Albert Einstein and other brilliant people showed us that classical physics breaks down in its ability to describe things if those things are very small, smaller than an atom, or if those things are moving very fast, near the speed of light. But we now know a lot about these realms too, which comprise the field of modern physics. And we will be ready to learn about that once we have completed our study of classical physics, since classical came first. And we still use these concepts to describe the motion of almost everything in the universe. Einstein himself once said that the most incomprehensible thing about the universe is that it is comprehensible. This means that through the language of physics, we have already begun the incredible task of knowing how the universe works on the most intimate level, and the technology we have been able to create is a working demonstration of our sophisticated understanding of physics, from computers and satellites to lasers and rockets. Whether we can one day know everything there is to know, we can't yet say. But we already know more than enough to keep you busy catching up for a while. So let's learn some physics.